In today's class, we'll be seeing damped oscillations. Now, this is also one of the important topics. Now, what exactly is this? I'll tell you. But remember, in damped oscillations, you will have three subtopics. One is general damped oscillations. Next, second type is forced oscillations. So forced oscillations is a different topic, and within forced oscillations you will have resonance. So these are the three main areas from which usually questions keep coming. Now, what is that you are supposed to do is to understand the subject better. You need to identify to which topic the question belongs first and then solve it accordingly. So in general damped oscillations, what will happen is, in SHM first, if you look at SHM, in simple harmonic motion, if you take for example say a spring mass system, what happens is you will be writing your net force is restoring force. This net force we will be writing it as MA, restoring force you will be writing it as minus Kx, and somehow you will manage to write it as A equal to minus omega naught square x in general SHM. Next, second, here you will be considering energy is equal to constant. Third, if you look at this A equal to minus omega square x, your equation of SHM is d square x by dt square plus omega naught square x is equal to 0. This is your general equation of SHM. For this, a general solution is x is equal to a sine of omega t plus phi. Something like this you are writing as the equation where phi is the phase. Now, this is what you have been doing, and here your time period is, if you take your time period, t is equal to 2 pi by omega naught, this is constant. So all this stuff is what in general for a general simple harmonic motion. This is your basic scenario. Now coming to your damped oscillations. Damped oscillations. Damping, if you take this damp word, that means there is dying of oscillations or forcing of oscillations. So there is some indirectly some damping force, means on oscillations, some external force involvement is there. On damping force, some external force is involved. So that is what you are calling it as your damping force. So what will this external force do in different cases, I will tell you. So in general, in damped oscillations, in damped oscillations, external force, what it will do is, external force, reduces amplitude, energy, it reduces amplitude, it reduces energy, and it will increase time period of oscillation, increases time period of oscillation. How? With maths I will show it to you, but this is your basic idea. Your external force will reduce amplitude, energy, and it will increase time period of oscillation. Now coming to forced oscillation, coming to your forced oscillations. Your forced oscillations are, your external force, external force will cause, external force will cause the, will cause or will maintain, will maintain the oscillation or vibration, without, without dying, dying in the sense reduction of amplitude. Okay, dying in the sense indirectly I am talking of reduction of amplitude. Okay, without reducing the amplitude it will try to maintain the amplitude. And in resonance, okay, it is a subcase of forced oscillation. Okay, resonance is subcase of forced oscillation. Okay, so I will explain it in detail, don't worry. But in resonance, okay, what will happen is frequency of external source. Okay, frequency of external source is equal to natural frequency of system. Okay, frequency of external source is natural frequency of system and amplitude is maximum. Okay, amplitude is maximum. Okay, so all of you, okay, I did not explain what is each in detail, but I am telling you in this topic you are going to generally study this, and your questions that you have are going to come from these three basic topics. Okay, and these three basic topics we will discuss in detail. Okay, hope you have understood what I am trying to explain here. Now, okay, so please do take screenshot, pause the video clip, remember this content. Okay, now what is this general damped oscillation? I will tell you. Okay, so now first let us start with general damped oscillation. Now, what is this damped oscillation means? Okay, let us say you have a spring block system. Okay, and its spring constant is K, and you have a block of mass M like this. Okay, right? Now, okay, previously if you ask time period, frequency, everything, you have clearly neglected friction. Okay, right? So without friction and with friction, two things are there. Okay, so without friction, what is that you have done? Okay, initially if the system is in equilibrium, if this block is of mass m, okay, if some small displacement x is there, then your restoring force will act this way. You have written restoring force, your net force is equal to restoring force. Restoring force you are writing it as minus kx, net force you are writing it as ma. From here a is equal to minus k by mx, a equal to minus omega naught square x, like this you are continuing. Now all this stuff is known to you and I have explained it previously. Now if you consider, okay, if you consider the friction, okay, if you consider the friction, okay, what will happen is frictional force, okay, if you consider the friction, then what will happen is frictional force, okay, when it acts on the block, it will try to reduce energy of spring block system. Okay, energy of spring block system. So energy will be reduced for this spring block system. Okay, now once energy is reduced, okay, before without friction, half kx square plus half you can write this is spring potential energy and kinetic energy, total energy is constant, but you cannot write that now. Okay, because okay, frictional in this case, okay, frictional force, what it will do is it will reduce the energy, so eventually oscillations will die out. Okay, so reducing energy in the sense it will reduce the kinetic energy, as well as if kinetic energy is decreasing, automatically potential energy will decrease. So okay, energy will be reduced. So reality, okay, as an example I have told you friction is there, but in reality if you take, there will be different kinds of forces. Okay, frictional force is one example, I can also say that, okay, I can also say that there is viscous force, okay, viscous force, okay, we will be writing Fv is equal to 6 pi n Rv, where n is coefficient of viscosity, R is the radius, V is terminal velocity of the body, okay. In fluid mechanics you have seen this, okay. So etc., okay, like this in reality there will be different forces. Now all these forces, okay, all these forces will reduce, okay, all these forces what they will do is they will reduce, okay, amplitude and energy, they will reduce the amplitude and energy. Now what is your target is, if you are given such a force, now what will happen to the amplitude, what will happen to the energy, what will happen to the velocity, this is what you are supposed to calculate, okay. Hope you have understood what I am trying to explain here, okay. So my point is, if you have these forces, what will happen to energy, amplitude is our ultimate target, and that is what is asked in the questions, okay. Now those who want to copy, you can pause the video clip, copy the content. Now let's continue further, okay. So now, okay, your system, let us say there is some system, and in this system, say there is a damping force in this system, let us say there is a damping force, okay. Your damping force, okay, your damping force, okay, is equal to minus B into V, okay. Usually damping force will be opposite to velocity, okay. Usually F damping will be opposite to velocity, okay. So that is why we are keeping a minus sign, okay. Now new system, okay, on new system, okay, say for example this system itself I am considering, okay, and because of friction or somehow some damping force it is varying like this, okay. Now if you look at this, okay, if you look at this kind of system in which damping is there, your net force is, okay, net force is your force because of restoring force, that is indirectly spring force, plus your force because of damping, okay, right. And this net force is, okay, normal SHM, okay, your net force is only restoring force, this we are writing it as minus kx, this we are writing it as ma. Here, okay, your net force is, okay, restoring force is minus kx, damping force is minus b into v, okay, right. Relax, if you have any doubts just let me know, okay. So what is that we are doing, basically we are adding an extra force, okay. Setup is same, similar setup, same equations. Now, okay, in normal SHM if you take, you are writing m d square x by dt square plus kx is equal to 0, d square x by dt square plus k by m into x is equal to 0. You are writing d square x by dt square plus omega naught square into x is equal to 0. This is your equation and the solution is x equal to a sine of omega naught t plus phi. Your time period is 2 pi by omega naught. Similar to this, here also this is a differential equation, okay. What is this? A differential equation. Now obviously for a differential equation, what is that we are supposed to do? We are supposed to give the solution. So now what I will do is I will rearrange. Acceleration can be written as d square x by dt square plus b times v. V is what? Dx by dt plus kx is equal to 0. Now, okay, this is a second order differential equation, okay. Now we need to rearrange this equation, okay. We need to rearrange this equation. Now if you are rearranging this equation, what will this become? D square x by dt square okay, what is your equation is d square x by dt square plus b by m times dx by dt plus k by m into x is equal to 0. Now, what is important out of this, I will tell you. Okay, so what is the equation? This is your final equation. Now, if you substitute b by m is equal to 2 gamma omega naught square, okay, frequency without damping as k by x, k by m, okay. So your equation, what it will become is, okay, after substitution, okay, what this equation will become is, I will go to the next slide or page. So pause the video clip, copy this content, okay. So first try to understand it. So the solution is, okay, your equation is, okay, your new equation is d square x by dt square, d square x by dt square plus 2 gamma into dx by dt, d square x by dt square plus 2 gamma into dx by dt plus omega naught square x is equal to 0. Okay, now what will happen out of this is your 2 gamma is b by m, omega naught square is k by m. Okay, now your general solution, okay, general solution to this equation is like how you have seen in SHM, a particular solution to the differential equation x is equal to a sin omega t plus phi. For this also, okay, for this also there will be a solution, that is your x is equal to, okay, right, a times, okay, x is equal to a times cos of omega dash t plus phi. Okay, now in this what is each term, I will tell you. Okay, it appears as if it is straightforward, but no. Okay, so in this what is the each term, I will tell you. Okay, very important, you should remember these results for solving problems. Your amplitude is, okay, your amplitude is a is equal to a naught. What is a naught? Okay, initial amplitude or initial position. Okay, xm, okay, in some books it will be xm, okay, but I am telling you, okay, so some a naught times e power minus gamma into t, okay, where, okay, this is your amplitude, okay, your gamma is b by 2m, a is equal to a naught times e power minus gamma t, okay. So from this what is the conclusion? Your amplitude decreases exponentially, okay. So now if you substitute t equal to 0, a is equal to a naught times e power minus 0, e power 0 is 1, so a naught times e power 0, that is equal to a naught, and okay, which obviously refers to initial amplitude. Okay, this is your a naught represents initial amplitude. At t equal to infinity, your amplitude is a equal to a naught times, that is after long time, minus gamma times infinity, that is a naught times e power infinity, any number to the power big number, it will become 0. Okay, oscillation dies. Okay, this is after long time. Okay, basically this is your amplitude. Now in the books you will be seeing a graph for this amplitude. Okay, so that is your displacement versus time graph, your displacement versus time graph. So what is it is, okay, what is it is, this amplitude, it will eventually keep dying off like this, so it will keep decreasing like this. So this graph you will see. Now if you look at this, your amplitude is highest value, so it keeps decreasing, eventually it will die out. Okay, so this is your amplitude. Now coming to frequency part, okay, so this is important, frequency also. So coming to the frequency part, I have written it as some omega dash. What is this omega dash means? Under root omega naught square minus r square. Okay, so this is your new angular frequency, okay, right? And coming to time period, okay, coming to the time period part, your time period is t is equal to 2 pi by omega dash. T dash is 2 pi by omega dash, which is equal to 2 pi times under root omega naught square minus r square. Okay, so obviously t dash is greater than t naught, where t naught is 2 pi by omega naught. Okay, so time period increases because of damping. Okay, that conclusion I can make. Okay, right? And the body undergoing this damped oscillation is known as damped harmonic oscillator. Okay, right? So pause the video clip, copy this content. If you have any doubts, just let me know. Okay, now coming to the energy part. Okay, I have given time period, everything. Next, coming to the energy. Okay, coming to the energy part. Energy in SHM, you will write half k a square. So here it is half into k is some a naught square e power minus 2 gamma t, something like that. Okay, wait, we will go to the next slide. Okay, or else things will become clumsy. First you copy this stuff. I will talk of energies and relaxation times. Pause the video clip, copy this, close your eyes, remember the content. Remember the formula of amplitude, remember the formula of frequency, angular frequency. Okay, now let's continue. Okay, so now if I continue further, okay, if I talk of energy, normally in SHM, if you write total energy is constant, so you will be writing half k a square or half m omega square a square, like this you will write. Now in this situation also, if you write half k into a is a naught times e power minus gamma t whole square, right? Here amplitude is varying with respect to this. So half k, I can write it as your energy of damped oscillation is half k a naught square times e power minus 2 gamma t. This term alone, if I assume it as E naught, this will become E naught times e power minus 2 gamma t. Okay, so that will become E naught times e power minus b by m into t. Okay, so this is your energy expression. Okay, this is your energy expression. Okay, basic questions, if they are asked, you can do it this way. Okay, right now, okay, what something new and special here is, okay, so there is some slight extra information that is required. What is that extra information is, you will have, okay, relaxation time in damped SHM. Okay, so I will keep the heading as relaxation time. Okay, so what is this relaxation time in damped SHM is time in which, basically it is time in which value of function becomes 1 by e. Time in which value of the function becomes 1 by e. Okay, so what is that, I will tell you. Okay, so your relaxation time for amplitude, if you take, you will keep it as tau a. Okay, relaxation time for, okay, let's change the color, relaxation time for velocity represented by tau v, okay, and relaxation time for energy, relaxation time for energy represented by tau E. Now if you take this part, okay, if you take this part, your amplitude is A is equal to A naught times e power minus gamma into t. Now, okay, so what is that I am telling you? At time t is equal to tau A, amplitude A is becoming A naught by E. So A naught by E is A naught times e power minus gamma t. A naught will cancel off. E power minus 1 is e power minus gamma t, relaxation time for amplitude. So gamma times tau A is equal to 1. Tau A is 1 by gamma, but gamma is what? B by 2m, no? So 1 by B by 2m. 2 gamma is B by m, gamma is B by 2m. So that will give you 2m by B. Similarly, okay, if you do the same, okay, if you do the same for velocity, your velocity also it will be in the form of some v equal to v naught power minus gamma t. Okay, so if that is the case, v naught by e is equal to v naught times e power minus gamma times tau e. V naught will cancel off. Minus 1 is minus gamma times tau power v. Tau power v is tau v is 1 by gamma. 1 by gamma is 2m by b. Okay. Next, if you take the relaxation time for energy, okay, if you take the relaxation time for energy, your energy expression will be, okay, your energy expression will be some, we have seen that it is E equal to E naught times e power minus 2 gamma into t. So E naught by E is equal to E naught times e power minus 2 gamma times tau E. E naught will cancel off. E power minus 1 is this one. So minus 1 is minus 2 gamma times tau E. So tau E is 1 by 2 gamma. Okay, previous values are 1 by gamma. So 1 by 2 gamma means 1 by B by M. Okay, so that is equal to M by B. Okay, now you are from this, okay, your ratio, relaxation time of amplitude, relaxation time of velocity, both are equal, which is equal to, okay, which is equal to, okay, this part m by b is what? Tau a. So 2 times tau e. Okay, relaxation time of energy, 2 times this thing. Okay, so this ratio they can ask you simple basic questions and you are supposed to remember this result. Okay, all right, now let's continue further. Okay, pause the video clip, copy this information, and in the problem solving I will help you out, don't worry, but mug up all these results, because in the mains exam that you will have a very limited amount of time. So within the time you are supposed to finish it off. So you should remember these results. Okay, right? So let's continue further. Now next, okay, another information that you have is, okay, quality factor. If it is asked, okay, it will come in alternating current, it will come in some other places, okay, waves and all, but almost everywhere the definition is same. But in according to our JEE syllabus, in which chapter the question comes, accordingly you have to substitute. So your quality factor here is 2 pi times, okay, 2 pi times average energy stored per cycle, average energy stored per cycle, whole divided by average energy stored by cycle plus average energy loss in cycle, which is equal to omega naught times tau, where tau is the relaxation time. Okay, whatever accordingly you have to substitute. Okay, so that you can do it, and if you have any doubts you can ask me. Okay, right, now let us write the summary. Okay, so your summary of what I have explained is, for damped oscillations. Okay, ultimately key takeaway in this lecture, what is that I have given, I will do that. So summary for damped oscillation is, okay, point number 1, your equation of damping is, no wait, okay, your restoring force plus damping force is your net force. Next, number 2, your equation is d square x by dt square plus 2 gamma into dx by dt plus omega naught square into x is equal to 0. Now what is this, I will tell you. Okay, 2 gamma is b by m, omega naught square is k by m. Next, solution to this equation is x is equal to a times sin, it's not sin, it is cos. Okay, usually it can be some harmonic function, it depends upon the initial phase. So you can even write sin of omega dash t plus phi, there is nothing wrong with it, but this phase angle will change accordingly. Alright, so the solution to this equation, if you take this amplitude, it is a equal to a naught times e power minus gamma t. That is your equation for amplitude. Your equation for angular frequency is under root omega naught square minus, okay, it's not 2 gamma, it is gamma square. Okay, it is gamma square, where gamma is b by 2m. Okay, right. Next, your next formula is, okay, here itself I will write, your time period is t dash is 2 pi by omega dash, which is of course greater than original time period. Then followed by your energy is E naught times e power minus 2 gamma t. Then relaxation time for amplitude, relaxation time for velocity is equal to 2 times relaxation time for energy. Okay, basically relaxation time is time for value to become 1 by e, time for value to become 1 by e. Okay, right. Next, quality factor q is equal to omega naught times tau. Okay, so these are the key conclusions that you can make from the explanation that I have given. Okay, so eventually that amplitude everything will die off and you are going to get a graph like this, I have told you, so it is covered. Okay, right. So pause the video clip, take a minute time, try to summarize everything. Okay, get the ideas printed in your brain, get the results printed into your brain. Okay, right. So let's continue further. Now your damped oscillation is basically situation where some external force is acting. Now next case is your forced oscillations. Okay, your next case is forced oscillations. Now in this, a sub part that you have, sub part of this is resonance. Okay, even though I have told you right in the start itself, but there is a sub part. Out of this forced oscillation, the sub part is resonance. Now why should we have forced oscillation is my first question. Okay, why we need forced oscillations? Okay, why means my answer is pretty simple. Because of dying oscillations, okay, bracket I can say reduction in amplitude, velocity, energy. Amplitude, velocity, energy. Okay, right. So because of dying oscillations, reduction in amplitude, velocity, in energy, okay, what will happen is, okay, we need to supply, okay, we need to supply external force, we need to supply external force to prevent damping, so to make the oscillations not to die out, we need to supply that external force. So to supply this external force, obviously what will happen is, okay, we need to supply this external force to prevent the damping. So to supply this external force, we are doing it. Okay, so now your external force is, okay, let us say some F external is some F. So your net force is force because of damping, force because of restoring force, plus force because of some external agent. Okay, now this external agent will provide force, okay, to prevent the damping. This external force also will be harmonic. Okay, this external force will be harmonic, that means it will repeat at regular intervals of time. Okay, because once you supply force only once, that force will do some work that will be getting converted into energy, and later damping will occur. But we want this to be periodic, okay, harmonic, and it is supposed to be periodic, because if it is not periodic, because of damping, oscillations will die out. Okay, it is supposed to be periodic. So now your equation is Ma is equal to your damping force some minus Bv, restoring force minus Kx, plus some external force is, I will write it as Fm into cos of omega m into t. Okay, so now in the books, okay, in this books, what is going to be this is, this external periodic force is called as driver force. It is called as driver force. Okay, right? Now in most of the books, okay, this will become, for you to not to get confused, I will write omega d. Okay, omega d is frequency of driver oscillator. Omega d is frequency of driver oscillator. Okay, omega d is frequency of driver oscillator. Okay, right, driver force or driver oscillator. Now once again it is a differential equation, we need to rearrange it. So if I do that, okay, d square x by dt square plus b times v dx by dt, I am sending terms to other side, plus kx is equal to Fm into cos of omega of driver into t. Now rearranging this equation, d square x by dt square plus b by m is 2 gamma dx by dt plus k by m is omega naught square x. This is equal to Fm by m times cos of omega d into t. Okay, previously you have learned these values, right, where your 2 gamma is b by m, omega naught square is k by m. Okay, right? So this is your new equation. Okay, so please pause the video clip, take a minute time, try to understand it. Okay, now let me continue further. Alright, so I will continue. So now you have this forced oscillations and you got this equation of, okay, what is your equation is d square x by dt square plus 2 gamma into dx by dt plus omega naught square into x is equal to damping force amplitude times cos of omega of driver into t. This is your equation. Now, okay, don't worry, this is in match, okay, higher order differential equations. Okay, you will have lot of this stuff when you are actually studying engineering maths. In third and fourth semesters you will have this. Okay, Lorentz equations, Lorentz transformations, like this different things you will be studying it. Okay, so but it is a higher order differential equation, and for this also there will be a solution. Okay, what is the solution to this equation is x is equal to a times, okay, So for any equation like this, obviously there will be a solution, and that solution is x equal to a sine of omega of driver into t plus phi. Now why here it is omega driver, I will tell you. Okay, your new frequency is omega driver because okay, why this is omega driver, because if you look at this scenario, okay, this external force is driver, so it will keep pumping energy, it will keep on happening. Okay, so your new frequency is because of the external source is the key thing, okay, that will keep pumping energy. So your system will try to behave with respect to that external source. Okay, so it will not have new kind of this thing. Okay, so this is omega driver. Okay, this is your driver frequency. Okay, so very important, keep this in mind. Now coming to your amplitude formula. Okay, so your amplitude result is, your amplitude value is, a is equal to, your amplitude value is a is equal to, in the numerator force amplitude by mass whole divided by under root omega driver square minus omega naught square plus, okay, it is 4 gamma square omega driver square. This is your amplitude. Okay, this relation is your amplitude and very important. Okay, now coming to phase. Okay, coming to the phase value here, your tan phi here is b omega d, b by m into omega d by omega naught square minus omega d square. Okay, you will study a lot of this in ECE branch and engineering physics some places. It depends upon which university you are in and what is your syllabus. But this basic information, how much is required, I have given it. Okay, now okay, an important point or note, that is in these oscillations, okay, in these oscillations amplitude and energy will remain constant. Amplitude and energy will remain constant because the purpose of this is itself to maintain this thing. Okay, right? To maintain constant values, because we have in reality damping. To prevent that damping itself, we are bringing some external force and we are causing this forced oscillation. Now even after bringing forced oscillations, if there is variable amplitude and energy, then there is no point in doing forced oscillations. Okay, so that is why I am telling you, in these oscillations amplitude and energy is constant. Okay, so to make it constant itself, we are using this forced oscillations. Okay, right? Now hope you have understood this and there are no doubts. Okay, now here, okay, something important I will explain. Okay, that is your resonance. Okay, so your questions can come from anywhere, but you should be ready. So what is your next topic is resonance, which is the last part. Okay, now when coming to resonance, okay, resonance, I am telling you very clearly, when frequency of external source, when frequency of external source omega driver is equal to natural frequency of system, natural frequency of system, which is omega naught. Okay, you can say resonance is achieved. Okay, you can say resonance is achieved. Okay, so now when what is this external source frequency and what is this natural frequency? Just now we have seen in forced oscillation we will be applying some external force Fm cos of omega d into t. Natural frequency is omega naught square is equal to k by m. So this omega d should be equal to omega naught. Okay, if that is the case, then you can say resonance will occur. Okay, right? So this type of resonance, okay, in resonance, this type case, your time period will be 2 pi by omega d, which is equal to 2 pi by omega naught, which is equal to 2 pi into under root m by k for a spring mass system. Okay, right? So this is your basic idea of resonance. Okay, don't worry. Okay, so basically, okay, it is a condition or subcase. Okay, so now what is the math part of this? I will tell you. Okay, don't worry. So the math part is questions will come from, okay, they will ask you questions like what is the amplitude in resonance? Okay, amplitude resonance. Okay, and velocity or energy at resonance, like that they will ask you different terms. So I will talk about that. Okay, so your amplitude resonance is, okay, so if you remember your forced oscillation, okay, look at this expression. What is your amplitude? A is equal to Fm by m by under root omega d square minus omega naught square plus 4 gamma square omega d square is what you have. So your amplitude is Fm by m by under root omega d square minus omega naught square whole square. Okay. It is actually omega naught square minus omega d square, sorry, omega naught square minus omega d square. Okay, I have written it wrong. We need to consider which is big, right? So omega naught square minus omega d square. Okay, as long as it is plus or minus, nothing, I mean square term, nothing will be affected. Plus 4 gamma square omega d square is your amplitude definition. Okay, now when will maximum amplitude occurs? Okay, when A max occurs, when amplitude maximum occurs, what will happen is, when maximum amplitude occurs, what will happen is your omega naught square minus omega d square, okay, omega naught square minus omega d square whole square plus 4 gamma square omega d square is minimum. Okay, right? Because this term is in denominator. Which term? This term is in the denominator part. So when, if you want numerator to be maximum, left hand side A to be maximum, this is supposed to be minimum. Now if I differentiate this equation, okay, if I differentiate d by d omega d of omega naught square minus omega d square whole square plus 4 gamma square omega d square term, if I differentiate it, it must be equal to 0. When minimum occurs, your first derivative of that particular function will be equal to 0. So if you do chain rule of differentiation, okay, BPC people or those who belong to medical stream, remember the end result. 2 times omega naught square minus omega d square times 2 omega d plus 4 gamma square into 2 omega d, this must be equal to 0. 2 to 4 omega d, 1 omega d will go off, you will get omega naught square minus omega d square, okay, is equal to 2 gamma square, okay, in resonance. So from here omega d square is omega naught square minus 2 gamma square, omega d is under root omega naught square minus 2 gamma square. So now don't think this is your this thing, okay, this is maximum amplitude. This is what condition for A max, okay, in, okay, condition for maximum amplitude, okay, right. But resonance in general will talk of frequency. In frequency resonance, omega d is equal to omega naught, okay, and in amplitude resonance, amplitude is maximum, okay. Here amplitude resonance, amplitude is maximum. So in this case, what is the condition means? This is the condition. How much is the A max value means? Substitute this back to get the final value, okay, right. Now next, okay, if you take velocity or energy at resonance, okay, previous one was what? Condition for maximum amplitude. Now if you take velocity or energy at resonance, a similar setup will be there, okay. Basically you will have, okay, you have x is equal to a cos of omega d into t plus phi is your equation. Your velocity is dx by dt, that is equal to a times omega d into derivative of cos is sine, some minus sign is there, but in general this is what you have. So this term is anyhow, okay, you can rearrange it and do whatever you want to, but if you consider the velocity amplitude, okay, if you consider the velocity amplitude, okay, your velocity equation will be, okay, so it is your v is a times omega d times, okay, if you are taking cos or sine, whatever you, that is of your choice, but what is the equation that we have given? For forced oscillations I have taken sine, right, so I will take sine. For this oscillation, damped oscillation, I have taken cos. For forced oscillation I will take not cos, I will take sine, okay, so a sine of omega d into t plus phi. So velocity is dx by dt, so this is a times omega d into derivative of sine is cos of omega d into t plus phi, okay. So this is your velocity equation, okay. Now once you get the velocity, okay, this term if you assume it as v naught, okay, so your, okay, maximum velocity is, okay, v max is a times omega into d, okay, all right. Now if you consider, okay, a, okay, what is a? Now your a value you have to substitute it, right, okay, so your a value is fm by m times omega d by under root omega naught square minus omega d square plus 4 gamma square, omega d square is your expression, okay. Rearrange the terms here, okay, and you can write it as fm by m times under root omega naught square minus omega d square by omega d whole square plus 4 gamma square. Like this you can rearrange, and this v max will be maximum, okay, if you assume it as some v naught, okay, so that is your maximum this thing velocity. So excuse me, so v naught will be maximum when denominator is minimum, and it occurs when omega naught is equal to omega d, okay. So this is your basic idea, okay. So now what are the key takeaways in forced oscillations and resonance summary? I will tell you, okay. So now your first idea is your net force is damping plus external force plus external periodic force, okay, some cos sine something like that, plus your damping external force you have, periodic force you have, plus restoring force you will have it. And the equation for this kind of SHM is d square plus x square plus 2 gamma into dx by dt plus omega naught square into x is equal to restoring force is Fm into cos of omega d into t. The solution to this equation is, okay, x is equal to a into sine of omega d into t plus phi. The amplitude value is a is equal to Fm by m by under root omega naught square minus omega d square whole square plus 4 gamma square omega d square. Now this will give you amplitude. Next, your omega d is, okay, in forced oscillations, your omega d is of external source, okay, external source, you call it as driver, okay, right. And your time period, obviously t dash will be is equal to 2 pi by omega d, right. Next, you will have, okay, you will have this in forced oscillations, okay. Now a particular subcase of this is resonance, okay. So in resonance, frequency of driver omega d is equal to omega naught. This is your frequency in resonance, and your time period is 2 pi by omega d, which is equal to 2 pi by omega naught, okay. And maximum amplitude occurs, okay, maximum amplitude occurs when, okay, maximum amplitude occurs when omega d is under root omega naught square minus 2 gamma square. I have derived the derivation. And your velocity or energy is given by, velocity, if it is known, you can give energy. So your velocity is Fm by m times under root in the denominator omega naught square minus omega d square by omega naught whole square plus 4 gamma square, okay. And this will be minimum when omega naught is equal to omega d, okay. So this is your summary, okay. So entire your damped SHM is in this screen that you have. Close your eyes, remember all these formulas, and similarly, okay, remember all these formulas for amplitude as well, okay, right. So please do, these two you have to remember, okay. So with this, lot of questions can be solved easily, okay, right. So now let us try to do simple questions. You can take from any standard book and then do it, okay. So I will pick from the books that I have within my reach. Alright, so you have a question like this. Basically you have a spring mass system whose mass is 20 kg, spring constant is 90 Newton per meter, and your damping constant is 40 gram per second. What is your question is, you are supposed to find time period, time for amplitude to become half of initial value, and time for energy to drop to half of the initial value, okay. So this is your question and you are supposed to do it, okay. Alright, so now try this question. Now if you are trying to solve the answer to this question, first omega naught is under root k by m, that is equal to under root 90 by 20, so under root 9 by 2 is 4.5, it is some close to 2.1, something like that, okay. This is your natural frequency. Now gamma value is what? B by 2m, okay, because your omega of damping, okay, if you are trying to solve the first bit, omega of damping is under root omega naught square minus gamma square for a forced oscillation. So gamma value is B by 2m. So unit of this term damping constant is B, 40 grams. So 40 into 10 power minus 3 kg by 2 times mass is 20 kg, 2 into 20, 40, 10 power minus 3, it is very small. So this is approximately 0.00 something, and this is close to 2.1 something. So this term can be neglected. So omega damping is close to omega naught only, okay, which is under root 4.5 something like that, because it is very small. Next, okay, your time period is finally it is 2 pi by omega damping. So you can simplify it accordingly and then substitute it. Now your second bit, time for amplitude to become half, A is equal to A naught times e power minus gamma t. A naught by t is equal to A naught times e power minus gamma is B by, okay, B by 2m into t. Apply ln on both sides. Ln to A naught will cancel off. That is equal to B by 2m into t. From here get the value of t, 2m into ln 2 by B. Okay. Now in chemistry, somewhere you will learn ln 2, ln 3, ln 4 in first order reactions. Chemical kinetics and all you will be learning this stuff, right? So it will not be a big deal for you guys to learn this content, okay? So substitute that ln 2, ln 3 values, and coming to energy expression, okay, for the third bit, your energy E is E naught times e power minus 2 gamma t. E naught by 2 is equal to E naught times e power minus 2 gamma t. E naught will cancel off. Ln 2 is equal to 2 gamma into t. T is equal to ln 2 by 2 gamma. Okay, so do these relations, okay, right? So substitute the value, simplify it. Ln 2 value is 0.693, mass value substitute, B value substitute, convert it into proper SI units and then simplify it, okay? So like this you are supposed to solve the different questions, okay? And for angular oscillations, in place of A you substitute theta, okay? For angular oscillations, okay, similar equation, everything is same except the fact that your theta is theta naught times e power minus gamma into t, okay? This is your angular amplitude equation setup, everything is same, okay? So with this your damped SHM resonance everything is done, okay? So take different books, take any standard question that you have, try to apply these basics, you will get the answers, okay? Remaining problem solving sessions, lectures, I will cover more examples. Conceptually this is more than enough, okay? And please do not lose marks from this topic in the mains exam, okay? Thank you.